Thanks, Sandy, and thanks everyone for coming to my seminar today on Australian earthquakes. So, well, we do get earthquakes in Australia. We've got a history of earthquakes here, and so what do we do about them? Well, here at Geoscience Australia we do a lot. We monitor them. We've got a network of seismic stations that receive seismic information. We do research and model the activity, create maps and that sort of thing, and also provide advice and information. So we've got a history of large earthquakes in Australia. This is a picture of the fault scarp from the Meckering earthquake back in 1969. We've got the Newcastle earthquake in 89, which caused a significant amount of damage and 13 deaths. The Kalgoorlie earthquake in 2010 did some damage to historic buildings in Boulder and some in Kalgoorlie as well. And the Ernabella earthquake back in 2012 in a remote area of South Australia also produced a fault scarp. So we do have a long history of earthquakes in Australia. This is a map of global tectonic plate motion, and you can see that the arrows indicate the movement of all the tectonic plates. So Australia is moving to the northeast, and it's one of the fastest moving continents around the globe, and it moves at a rate of about 6 to 7 centimetres a year. So in Canberra we're moving at about 58 millimetres a year, and in Karratha we're moving about 70 millimetres a year. So we're moving in a northeasterly direction towards PNG, and we're situated on the Australian plate, which I'm outlining here. And so all the earthquakes that occur in Australia are occurring in an intraplate area, so away from the tectonic plate boundaries. So what causes earthquakes in a local sense? Well, it's caused locally by faults and fractures in the Earth's crust. We have a range of different fault types. So we have a strike-slip fault, where faults are moving sideways past each other. Normal faults, where the crust is moving away from each other. And thrust faults, where the crust is moving towards each other, such as occurs in subduction zones. So how do we measure earthquakes? Well, here's a schematic diagram of what one of the seismic stations look like that we receive information for in the Tsunami Warning Centre. I just want to highlight, this is the vault with the seismometer here, the dish, the solar panel and the acquisition equipment. And so every earthquake produces a seismogram, and this is a seismogram up here. So we've got a P arrival and an S arrival, and we can calculate the magnitude of an earthquake by calculating the distance from the P and S arrival to calculate the distance here, and then measure the amplitude from the lowest amplitude to the highest amplitude to calculate, and together these two things you can calculate the magnitude for. So here's another schematic diagram of 3 seismic stations. So we've got 3 seismic stations here highlighted in blue, and this is the location of the earthquake, so the earthquake's epicentre. So when an earthquake occurs, the seismic stations pick up the P and S arrivals from the seismic waves, and because we know the travel times that it takes for an earthquake to travel a certain distance, we can calculate the arrival from the epicentre back to the seismic station and calculate the location of the earthquake. So this is for 3 seismic stations. With more seismic stations we can reduce the error of the earthquake's location. And this sort of thing is done automatically by our system in the Tsunami Warning Centre. So why are earthquakes felt differently? Have you ever wondered how an earthquake feels if you haven't felt one before? Well, these spheres show the relative energy of earthquakes from magnitude 4 to 9. So I've got a sphere for a magnitude 4, and here's the magnitude 9 sphere. So the release of energy from an earthquake increases 32 times for every single unit of magnitude. So I've just got a few examples here of different events that have produced historic magnitudes. And so the Newcastle earthquake that occurred in 1989 was about 32 times, released 32 times less energy than the Meckering earthquake did in 1968. And then we've got, for a magnitude 10 earthquake, which is equivalent to a meteorite hitting the Earth. So it's significantly larger than the magnitude 9. So why are earthquakes felt in different ways? Well, it relates to a few main factors. Your proximity to the epicentre. So if a large earthquake occurs and you're hundreds and hundreds of kilometres away, you're unlikely to feel this event or experience any damage, whereas if you're located on top of the epicentre, you will feel the ground shaking. It also relates to the composition of the ground, whether it's hard rock or soft sediments, and what you were doing at the time. So if you're sitting watching the TV, you're more inclined to feel the ground shaking for a small tremor than you are if you're driving along in your car. So one way of measuring the ground shaking is we use a Mercalli intensity scale here, modified Mercalli intensity scale. And here's a table of some example events from historic earthquakes around Australia and their expected impacts on buildings. So if we compare the event in the Kalgoorlie CBD in 2010 to the Boulder CBD in 2010 for the same event, you had you had collapses of buildings and that sort of thing in Boulder, which was closer to the epicentre, compared to just cracks in masonry for Kalgoorlie. And then going up to an MMI of 7 for the Newcastle earthquake in 89, you had severe damage created to unreinforced masonry buildings and damage to some houses. And this is for the Christchurch earthquake in New Zealand in 2011, where you had heavy damage to unreinforced masonry buildings. So earthquakes can be felt in different ways, and there's a subsequent effect on buildings as well. So this is a map showing Australia's earthquake history, and it's of earthquakes that have occurred in Australia in the last 50 years. So a map of Australia's most significant earthquakes in the last 50 years. And the table on the right shows significant earthquakes that have occurred in Australia. So at the bottom of the table here I'm showing the Newcastle earthquake, the 5.6. And the largest recorded earthquake in Australia was a magnitude 7.5, which occurred offshore Exmouth in 1906. And this was measured by the MMI, so we didn't have an instrumental recording for this event, but it relates to the MMI scale. And just to sort of pick out a few, so we've got the Meckering earthquake, the Tennant Creek earthquake over here in 1988, well there was 3 in 1988, ranging from 6.3 to 6.7. And the most recent large event was the 1997 earthquake that occurred off Collier Bay in WA in 6.3, which was a 6.3. And this was Australia's most recent large magnitude event, and that was 18 years ago. So in comparison to the Australian earthquake experience to the rest of the world, this is a map showing historic earthquake activity globally. And I just wanted to highlight a few of the recent events, large recent events that have happened around the world. And you can see from this map that there is a pattern here related to tectonic plate boundaries. So I'm just tracing some boundaries now. Looking back in 2011, I've highlighted the Japan earthquake in 2011, which resulted in a tsunami as well. Earlier this year we had 2 earthquakes in April and May in Nepal. and there was 2 in PNG, 2 large ones in PNG in the Bougainville region, and then a couple of weeks ago we had some large events in Chile as well. So these large events are occurring on plate boundaries, which is different to the Australian situation where we have all our earthquakes occurring in an intraplate area. Okay, so looking at Australia again now. This is a map showing earthquakes that have occurred in Australia back in last year. Red highlights all those events that have occurred last year, and grey highlights historic events from 2004 to 2014. And you can see that there's a concentration of activity in WA and in the southwestern part of WA, in the Flinders Ranges area of South Australia, and also in the southeast of Australia, New South Wales and Victoria. And not much activity in Queensland. So have a little guess and have a figure in your mind as to how many earthquakes you think Australia might have had in 2014, and I'll reveal it for you on the next slide. So this is a breakdown of earthquakes that occurred in 2014, and as I said, WA is a standout. We're receiving 331. Then South Australia with 137, followed by New South Wales, and poor Queensland was a bit quiet in 2014. So I don't know what figures you've all got in your mind for how many earthquakes occurred last year, but over 600 occurred around Australia last year. That might be a bit of a surprise to some of you. So far this year we've had 352 earthquakes in Australia. So we've got a bit of catching up to do compared to last year. But earthquakes are based on averages as well, so what we get in one year doesn't always reflect what we'll get in the following year. So generally around Australia we'll get about 400 earthquakes above magnitude 2 or so every year, and last year well exceeded that. We get a magnitude 4 about once a week, and a magnitude 5 once a year, and we've really exceeded that as well so far, which I'll go into shortly. We get a magnitude 6 on average once every 10 years, and as I mentioned, the Collier Bay earthquake in 1997 was our last one above magnitude 6, so it's been 18 years since our last major magnitude 6 earthquake in Australia. Isn't that interesting? So far this year, I'd like to just highlight some of the larger, more significant earthquakes that we've had. So there's a 4.5 off Broome a couple of weeks ago. We had a 4.8 west of King Island. And we had quite a bit of activity in Queensland. So in February we had a 5.2 near Eidsvold. This was followed by some aftershocks as well. And we had 3 magnitude 5 earthquakes up offshore Fraser Island. And just last night actually there was a magnitude 4.4 in the Pilbara. So we had some felt reports from some mine sites nearby, and that was that the location is to the east of the Roy Hill mine. So, and that was a 4.4, so that's another interesting event. So now I'm going to look at the Fraser Island earthquake sequence that we've had. So this is an animation, if it works. Yep. So keep your eye on the time and the radiating circle. So that's for the first one, the 5.4. That's for the 5.3 and the 5.1. So I'll just play that again because I want you to focus on, so these concentric circles relate to the MMI scale, so the amount of shaking that people experience. So these earthquakes were felt along the Sunshine Coast, from Bundaberg and into the Brisbane CBD as well. So zooming in on this area, there was 13 separate events, so 3 above magnitude 5 and 10 aftershocks. And the area is located about 120 off the coast, and we received 3,000 felt reports for all the magnitude 5 events. So it's quite a few people felt them up and down the coast. Looking at a bit more detail, as I said, the sequence started on the 29th of July. There was 13 separate earthquakes recorded. And this is very interesting for one of Australia's least seismically active states. In 2015, Queensland experienced the largest number of magnitude 5s in a century, and this includes the 5.1 near Eidsvold. The most significant earthquakes in southeast Queensland historically, we had two in the similar area to the Fraser Island quakes. So there was two earthquakes in 1918, so the magnitude 6 and magnitude 5.7 both on the same day, and the magnitude 6 was the largest ever recorded. And there was also a magnitude 5.5 at Gayndah in 35. So there is a history of large earthquakes in Queensland, in the southeast portion of Queensland. So this event was felt 300 kilometres from the epicentre, from Gladstone in the north and down to the Gold Coast as well. There was minor damage reported in some of the areas closer to the epicentre along the coast, with cracks to windows, walls and tiles. And buildings were even evacuated in the Brisbane CBD for the magnitude 5s. We issued a nil tsunami threat after each magnitude 5 event, and this is because of the earthquakes of where the earthquakes are located, and there's a history of earthquakes in that area, and also because of the location on the continental slope. And the potential we don't know whether or not there was going to be potential for a higher magnitude earthquake following the events. So it was a precautionary measure to issue the nil tsunami threats. So the earthquake sequence, in a bit more detail, looking at some modelling for this, the return period for potentially damaging ground shaking for the Sunshine, Brisbane and Gold Coast is about 1 in 1,200 years for rocky sites, and reduced to 500 years for soft soil sites, because the softer soils accentuate ground shaking. Earthquakes were not considered in building design until 95, and therefore older structures tend to be more damaged, particularly on the soft soil sites. Some Queensland buildings, such as the taller towers, are designed to withstand severe wind, and this gives them significant earthquake resistance. However, clustered earthquake events are likely to lead to worse consequences, as each event progressively causes more damage. For example, this occurred during the Christchurch earthquake sequence in February of 2011, where buildings that were repairable after the first event progressively got more damaged and with aftershocks and had to be demolished. So the likelihood of future earthquakes. So there is the chance of a magnitude 6.5 earthquake off the Sunshine Coast is about 1 in 5,000 years. And this size earthquake is unlikely to generate a tsunami. Recent research by the University of Sydney indicates that there is a potential for submarine landslides off the Sunshine Coast, but it's thought that a magnitude 7 earthquake would be required to generate a significant tsunami. And the chance of a magnitude 7 earthquake occurring on the continental slope of southeast Queensland is about 1 in 20,000 years. Who's that? Okay, so now I'm going to look at the earthquake monitoring that we do here at Geoscience Australia as part of the Earthquake Alert Centre, which is also part of the Joint Australian Tsunami Warning Centre, which we operate here at Geoscience Australia with the Bureau of Meteorology in Melbourne. So how do we undertake this monitoring? Well, we've got Australia covered in seismic stations. We've got a network of the Australian National Seismograph Network, which is highlighted in yellow, and the Joint Urban Monitoring Program network as well. So together we've got Australia covered in about 100 stations. So we're able to do sort of adequate monitoring of our continent, and I should also mention we've got stations on the offshore territories as well. This is just an example of a couple of the stations from the seismic network. So this is Eidsvold. So this is a typical station layout. So you've got a vault which contains, this is looking down to the vault, which contains the accelerometer and the seismometer. You've got a hut which contains all the communication and recording equipment, a solar panel and a satellite dish for communications. And this network is maintained by staff at Geoscience Australia. So how do we respond when an earthquake occurs? So we monitor seismic activity in Australia and our region. So when an earthquake is felt and has a magnitude 3 or above in Australia, the duty seismologist will analyse and notify of that event occurring within 10 to 20 minutes of the origin time of the earthquake. So that's when the earthquake is initiated. And we provide advice and information to the government and the general public. And this is an example of the screens that we have in the warning centre, receiving real-time information. This is an example of the Bowen earthquake in 2011. And it's these screens that are our first warning that an earthquake is coming before the alarm goes off. So what do we do? What's a typical response to an event? Well, using the example of the magnitude 5.3 earthquake that occurred offshore Fraser Island on the 1st of August, this is a typical time frame for what we do. So about 4 minutes after the origin time of the earthquake, we receive the first emails and phone calls from the general public talking about what they felt during the earthquake. At 6 minutes after the origin time, the alarm sounds from the detection system. At 9 minutes, the duty seismologist notifies the Attorney General's Crisis Coordination Centre and the Bureau of Meteorology. At 10 minutes, the event is published on Geoscience Australia's Earthquakes website, and we also publish on Twitter, and that was at 14 minutes for this event. At 16 minutes, the Bureau of Meteorology issued the nil threat tsunami bulletin. And this is a fairly typical sequence for any event that is notifiable. So how do we respond following the event? It's our job to inform the community that an event has occurred. And through the Crisis Coordination Centre, our information is channelled to them, and they produce an earthquake notification and maps as well. So this is a couple of examples of the type of maps that are produced, and it's these maps that are delivered to government ministers, and if it's a significant event, we'll notify the Prime Minister as well. As I mentioned, we publish information on our website. This is a screen grab of what our recent earthquakes page looks like. We get many visitors to the website when an event has occurred, and also for people finding out about details of an event if they have relatives living in an area where there has been an earthquake. We also publish on the Twitter page as well, which provides the public with another source of information. It's the duty seismologist and the senior seismologist's responsibility to also provide advice and information to the media. So we might do newspaper interviews, and it's a couple of newspaper articles there, and an Insights article, just some examples of some newspaper articles from the recent earthquakes, and we also do TV interviews as well to provide information if needed. And this is important from a government agency's point of view to provide correct, up-to-date information to the general public. So, what do Geoscience Australia's scientists do when an earthquake strikes? Well, we do several things. We go out into the field and deploy rapid aftershock kits around the earthquake epicentre. We do site assessments of the damage. We do research, modelling and mapping to provide a knowledge base of earthquake history around Australia and provide advice and information to the government and the community. So looking back to February in the Eidsvold earthquakes, the magnitude 5.2 earthquake, there was 4 large aftershocks after that event, which ranged from magnitude 2.5 to 4. It was very widely felt inland and in the coastal region as well. So Geoscience Australia scientists deployed some temporary seismometers around the epicentre of that earthquake, which was east of Eidsvold. And this is an example of the kind of temporary aftershock kits that we deploy. And there's the seismometer as well there, which you need to dig a hole for that. It goes into the ground to record around the epicentre. So 4 seismometers are usually installed after an earthquake. For this event, the temporary aftershock kits were left at the site for a 2-month period. And during that period, 260 smaller aftershocks were recorded. And this is important because the larger ANSN seismic network wouldn't pick up the smaller aftershocks, so it's important to record this information. It took several months for this information to be analysed by our seismic analysts, who go through the data minute by minute to check whether or not there's been any aftershocks. So it's a very time-consuming process, but very important. And this work is ongoing. More work needs to be done. So I should just mention that the yellow dots highlight the aftershock locations. So more work still needs to be done on this data set to better constrain the earthquake locations. A couple of earthquakes occurred out in Ernabella in South Australia, which is a remote area south of the Northern Territory South Australia border, and 320 kilometres south of Alice Springs. There was 2 events, one in March in 2012, which was a magnitude 5.4, and another one in 2013, which was a 5.7. And the 5.4 was Australia's strongest earthquake for 15 years. There was reports of strong shaking near the epicentre, and Geoscience Australia scientists went out and visited this area and mapped a fault scarp that was created from the earthquake, which was 10 centimetres high. So you can see here's the GPS here for scale, and about 1.6 kilometres long. Another thing that we do is produce maps of the ground shaking, which relates to the MMI rating that I mentioned earlier, and these are called isoseismal maps. So when we receive felt reports from the general public about their experience of ground shaking, this information feeds into these isoseismal maps. So this is an example from the Newcastle earthquake in 1989, and you can see the epicentre over here highlighted with the purple triangle. So the epicentre is away from the CBD near Lake Macquarie. However, if you look at the MMI rating, we had an MMI rating of 8 further away from the epicentre in the CBD. And this was due to semi-consolidated sediments are in the CBD area, which accentuated the severity of ground shaking in that area and contributed to the loss, the amount of damage in the area. In comparison, this is an isoseismal map for the Maui earthquake in 2012. We received about 10,000 felt reports for this event because it was felt in Melbourne. So the epicentre was a couple of 100 k to the east of Melbourne in Maui. And so around the epicentre we've got the highest MMI rating, and this was felt right out into Gippsland, northern and western Victoria as well. And so this shows just the concentric circles given to the isoseismal map based on the felt reports, so based on what people experienced from the earthquake. This is the National Seismic Hazard Map, which is produced based on historic earthquake activity, based on geological terrain, so whether it's cratonic, non-cratonic or extended continental crust, and based on ground shaking models as well. So this map is updated about every 5 years, and with the recent earthquakes in southeast Queensland, I'm imagining that this area might change a little bit with the next model, but we'll wait and see. Another thing that we do following earthquakes is to undertake assessments of the vulnerability of an area. So this is a map of the Newcastle area, and the purple dots show the buildings surveyed. So scientists undertake the survey to assess the building damage, identify factors contributing to the vulnerability of the buildings, and also develop an understanding of the relationship between the severity of shaking and losses. After the Kalgoorlie earthquake in 2010, another survey was undertaken. So the map on the left shows the survey locations of the buildings that were surveyed. Here's the epicentre down here near Boulder. And the map on the right shows the isoseismal map that was created. So the survey, the scientists that surveyed the Kalgoorlie area asked people questions in the town to better understand the MMI rating. So we've got a better understanding of the amount of ground shaking. So we've got MMI ratings of 4, 5 and 6, so yellow, blue and red. And we've got a stronger MMI rating down here close to the epicentre around near Boulder. So there's a lot of reds down here, and this was given an MMI rating of 6, this region. So there's a lot more damage in the Boulder area compared to up towards in Kalgoorlie. So it's important follow-up work that we do after an earthquake has happened. And here's some earthquake scenario models that are created. So I'm going to show a series of 3 slides here that show different earthquake scenarios for 3 events for the Perth area. So this is a map showing the severity of ground shaking for a magnitude 4.2 earthquake that is modelled off Rottnest Island. And so, you know, most of the mainland is given a rating of 4.5 to 5 there, and that's for a 4.25 earthquake. For a larger earthquake of magnitude 5.57, which is a 1 in 500 year event, you're getting some stronger MMIs over here, so getting MMIs of roughly 5 to 5.5. And then for a 1 in 2,500 year event, which was magnitude 6.4 earthquake, you've got a rating of 7.5 for Rottnest Island, and the Perth coastal strip was given an MMI rating of 6.5 to 7. So this is modelling about how to understand the severity of ground shaking, what it would look like if we had events of this size. Okay. We also pick up unusual events in the Tsunami Warning Centre, and one of these occurred last year in 2014. It was, I don't know if you can remember on the news, but there was a truck explosion out at Charlieville in outback Queensland. The explosion was picked up on a couple of seismometers at Quilpie and Roma, which were hundreds of kilometres away from the truck explosion. So, I mean, this seismogram, it looks a little bit messy, but at the time, the duty seismologist was sure this was an earthquake. So the truck explosion occurred at about 9 o'clock local time, resulting in 2 separate explosions, with the larger one being with the second one being much greater than the first. And there was a large crater in the ground resulting from the second blast, and so the truck driver and emergency services who were on the scene escaped with their lives, luckily. But initially, the earthquake was the truck explosion was thought to be a magnitude 2.2 earthquake, which was separate to the explosion, and 25 minutes apart, or 20 minutes apart. So we thought they were two separate events. Later that week, we were asked by the Queensland Department of Environment to further investigate the explosion time, and an alternate time for the explosion was identified, putting the explosion at the same time as the earthquake. So these were the same event, and this is the location. So it's about 30 kilometres south of Charleville there, on the highway. The original earthquake location was sort of a bit further south and off the highway, and this is what it looked like. So you can see why, with the size of this crater, that the explosion reached the seismometers hundreds of kilometres away. And debris was thrown hundreds of metres from the site, so this is a bit of concrete from the bridge. Yeah. Okay, so winding up now. Do you know that you can fill in a felt report if you felt an earthquake in Australia? Geoscience Australia, through our webpage, provides a means where the general public can report what they've experienced during the earthquake. And I've shown that this can actually assist in our earthquake research. So you can fill in an online felt report, just highlighting down the bottom here, and visit the website for other information about recent earthquakes that have happened as well. So do you know what to do when an earthquake happens? We might not get large earthquakes in Australia, but it's important to know what to do when an earthquake occurs. So it's important to know if you're living in an earthquake-prone area. Thinking back to the maps that I showed earlier on, do you live in one of these regions? Because you need to know what to do. So it's important to drop to the ground, because you don't know how long the earthquake is going to continue for, and seek cover under a table. And hold on, because you don't know how long the event will go for, and you don't know whether there's going to be any aftershocks. So this is what to do if you're inside. It's important to stay inside if an earthquake is occurring. Don't run outside. However, if you are outside, don't run inside. So stay outside, stay away from the building. So for further information, you can visit our Twitter feed, visit the recent earthquakes page, and there's a lot of teacher resources as well that are available on earthquakes and plate tectonics. And you can also look up the emergency action guides from the Attorney General's Department. So I'd just like to thank those people up there for helping me put together the presentation today. I'll take some questions if there's any.